Hi, everybody. My name is Isabella Greiner,
And I'm Jerome Foronda.
and today we're going to be going over our project two. Let's first start with how we're going to break down the presentation. So first, we're going to go over the design and the approach and some inspiration we had when it came to coming up with this idea. Then we're going to go into the certain challenges we faced when it came to the design and the modeling process. And finally, we're going to do a bit of a demo and sort of show you the final design we came up with. But first, let's do the design and inspiration. So, how did this all start? Well, Jerome has this little Lego jazz figure on his desk or table, where he has a little trumpet, and it looks like he's playing it. So he came up with the idea of maybe we could create a mechanic or a slider with a gear that makes it so when you turn the gear, it attaches to the trumpet and slides back and forth. It makes it seem as if he is playing the actual trumpet, sort of animating this little Lego figure. From there, we got to sketching. In these initial sketches, you can see I was kind of thinking, oh, maybe I'll have the gears and the slider all sort of on the same line and plane. But as you can see from those two, the left and the right designs, they looked very clunky, they were very messy. And so later we decided to shift into instead having it almost look like a straw structure where the gears are on the side where it's being held. And of course, the slider just has its own area. From there, we began doing certain measurements. So measurements Jerome took were of course, the length that the little Lego figure is with his trumpet, the sort of size of the thing that would connect the trumpet to our slider, the trumpet itself, and of course, the height of the actual trumpet player. With the height picture, I was also able to go into Procreate and draw a very clean, straight line from the vertical line of the trumpet player, and of course the line that the trumpet lies on. This enabled me to take that angle and make it so when we do our slider component, it's angled slightly upward and it won't look like it's out of the mouth of the actual player and it won't look clunky. It'll look like it's actually being played. Finally, we have our final design. As you can see, we incorporated that almost straw-like structure where we have the main stand and then the frame for the slider. It's angled slightly upward, so it'd be at the right angle with the trumpet player. Our gears are on the side, but they're not too large that they will appear so obvious when you actually are cranking it with the trumpet player. During this design, I was kind of thinking a lot about the slider itself and how we would go about modeling that component. And as you'll see later, it ended up getting changed from my original design. And it only goes to show that when you're designing something on paper, it's a lot different than when you had to actually model it and print it in real life. But from this main picture, we were able to get the general shape and idea of how we wanted everything to connect. And of course, later you'll also see how we got that slider component to fit into that frame. We will end up removing one of the pieces and make it detachable. But for now, I'm going to pass it off to Jerome to go into the challenges.
All right, so challenges. We had a lot of challenges this project. First of all, we had a little trouble trying to decide what we wanted to do, and we decided to, like Isabella said, work on this like little jazz guy that had a little trumpet, and we wanted to make the trumpet go um to this location in here. And dimensioning the parts in SolidWorks was a bit um was a was a bit hard to do because SolidWorks is a new program for us, and we both use different programs. But it was okay. It was a nice learning process. There were some areas, especially in the assembly, where it was hard to figure out how to mate things together. I spent a couple hours like learning how to do that. And the 3D printing, that was also another area where we had a little trouble because some of the dimensions wouldn't fit correctly when it got 3D printed. And we just like did a couple 3D prints, and we also did some sanding to make sure things would fit and things would slide properly. And then number three, we got the motion demo right here, and then it's gonna be played right now. So that was a cool demo of the assembly, how it would like go as we rotate one of the gears. And then this is our render design as well. You can see all the parts. Yeah. And then let's see it in action. Here's a video of me playing with it in person. So this is the Lego thing that we decided to build our project on. And yeah. And then here are the parts. As you saw in the rendering, these are all the parts. These are the sliders that you could connect to make the inside right here. The slider go here. Here's the two gears, and then this is like the stick that connects the sliders and the gears. So this is the constructed assembly. So it's all connected, and as you see, I put Lego parts inside here, or Lego connectors. And as you see, if you move this gear, this will slide up and down. So yeah, pretty cool, pretty cool. Now let's see it in part of the actual figure. So as we rotate the gear, the trumpet goes up and down, as you can see right here. Now let's see this with the Lego figure. So this is the project on top of Lego. I was able to construct this piece to fit a 4x4, but it's standing on a 3x2. So as we crank the lever, or the gear, the trumpet's going in and out. Alright, looking at the front, we have our model right here in the back. And then as we rotate the gear in the back, you can see that it looks like the musician is playing the trumpet. So yeah. And yeah, so that's pretty much it. Is there another one?
Yeah, thank you all so much for
Yeah.
listening, and we're excited to see your projects as well. Have a good one.
All right. Bye-bye. Cool.